Hey everyone, I'm Kabir Lesharan. So on my blog, I've started this journey of, really getting deep into data structures and algorithms. And I figured, why not bring you all along with me? We're going to kick things off with the absolute bedrock of DSA, arrays. Doesn't matter if you're just starting out or, if you're like me and just want to make sure those fundamentals are rock solid, this one's for us.
All right, so here's what we're going to cover. First, why do we even need arrays? What problem are they solving? Then we'll dive into what an array actually is and the rules you got to follow in Java. After that, we'll get practical with indexing and length, peek under the hood at how memory works with arrays. And finally, we'll see why this is your first big building block for everything else in DSA. Let's get into it.
Okay, so first things first, why do arrays even exist? Let's start with the core problem they were made to fix.
So let me ask you this. Imagine you're coding something, and you need to store, say, the names of 50 friends. How would you do it? Seriously, just think about it for a second. What would your first instinct be?
Okay, so if you're like me, your first idea is probably just make 50 variables, right? Like friend 1 equals Ravi, friend 2 equals Priya, and so on, all the way to friend 50. But, you can already see the problem. It's just messy. It's a pain to manage, and what if you get a 51st friend? It's just not a good way to do things.
And this is precisely where arrays come in to save the day. They're such a clean, elegant solution. An array is basically a way to group a whole bunch of related things, like all those friend names, and store them under a single name. So much cleaner, right? It makes your code way more organized and just easier to handle.
The way I always picture an array, and this really helped me, is to just imagine a row of empty boxes on a shelf. That's it. Each box has its own spot, its own number, and you can put one thing in each box. Just hold on to that picture. The whole boxes on a shelf thing is going to make a lot of sense when we start talking about things like indexing in a bit.
All right, so that's the simple idea, the boxes on a shelf. Now that we've got that in our heads, let's get a little more technical and look at the textbook definition.
So here it is. An array is a collection of elements. But here are the two key parts. They're all the same data type, and they're stored in contiguous memory locations. That word contiguous sounds fancy, but it just means they're all lined up right next to each other in your computer's memory. One after another, no space in between. And that simple fact that they're all together is what makes arrays super fast.
Okay, so for this whole series, I'm going to be using Java as the example. So let's look at the specific rules for arrays in Java, because there are a few things you really need to know.
So in Java, there are two really big rules for arrays that you just can't break. Rule number 1, everything in the array has to be the same type. You can have an array of integers or an array of strings, but you can't mix them. This is called being homogeneous. And rule number 2, and this is a big one, the size is fixed. Once you decide your array will hold, say, 5 things, it's always going to hold 5 things. You can't make it bigger or smaller later on. That's it.
And this is what it looks like in code. You start with the data type, like int or string, followed by those square brackets. Then you give your array a name. The really important part is this new keyword. That's the command that actually tells the computer, hey, go find a chunk of memory for this array. And you tell it exactly how big it should be. It's all happening right when your code is running.
Awesome. So now we know how to build a shelf. The next logical step is, how do we put stuff in the boxes and take it out? This is where indexing comes in.
Okay, listen up, because this is maybe the single most important thing to remember about arrays, especially when you're starting out. The numbering, it starts from 0, always. The first item is at index 0, the second is at index 1, and so on. Not 1, 2, 3. It's 0, 1, 2. This trips up everyone at first, but once it clicks for good.
Let's make this super clear with an example. Say we have an array of integers with the numbers 2, 7, and 8 inside. To get that first number, the 2, you'd ask for the element at index 0. To get the 7, you'd ask for index 1. And for the 8, you'd ask for index 2. See? 0, 1, 2. It's really that straightforward once you remember the 0 start rule.
And this leads to a super handy little formula to remember. The last index of any array is always its length minus 1. Always. So in our example, the array has 3 things in it, so its length is 3. But the last index is 3 minus 1, which is 2. Getting this mixed up is how you get that famous array index out of bounds exception error. So just burn this into your brain. Last index equals length minus 1. It'll save you so much trouble.
All right, let's peel back another layer. We're going to talk about memory now, and I promise, understanding this is one of those aha moments where everything starts to make a lot more sense.
So remember our boxes on a shelf? Here's the cool part.
What's actually in the box depends on the type of data. If you have an array of integers, that's a primitive type, the box literally holds the number. Simple. But if you have an array of strings, that's a reference type, the box doesn't hold the string itself, no. Instead, it holds an address, like a little note that says, the real string is over there in memory. So for integers, the value is in the box. For strings, a pointer to the value is in the box. Big difference.
This brings us to a word you'll hear a lot, mutable. It just means changeable. Arrays are mutable because you can change what's inside the boxes. You can take the number 7 out of a box and put a 10 in. That's fine. But, and this is the key thing, you can change the contents, but you can't change the size. Going back to our shelf, you can swap the items in the boxes, but you can't add more boxes to the shelf. The shelf itself is fixed.
Okay, let's start to bring this all home. We've talked about a lot of details, but why is this so important? The reason is simple. Arrays are the #1 most fundamental building block for pretty much everything else you're going to learn in DSA. So, what are the big takeaways? 1. Arrays are for storing groups of the same kind of data. 2. Their size is fixed once you create them. 3. We always use zero-based indexing to get to the elements. And 4. Knowing that memory difference between primitives and objects, that's your secret weapon for understanding what comes next.
And really, this is the main point I want you to walk away with. So many other data structures, lists, stacks, queues, are built on top of the idea of an array. If you can get really comfortable with how arrays work, you're setting yourself up for success for the rest of your DSA journey. It's that important.
So, to make sure this all sticks, I'll leave you with one final question to think about. What is the single biggest difference in how an array of ints and an array of strings use memory? If you can answer that, you've really understood the core concept here.
And that's a wrap on our first day. I really hope this gave you a good, solid starting point with arrays. Like I said, you can also read my full blog for a deeper understanding. The link is right there in the description. Thank you so much for learning with me today. I'll catch you in the next one.